In this question, before proving this relation, let us consider a fraction 1 upon square root of x plus square root of x plus 1. It is a fraction with its denominator irrational. So, in order to rationalize the fraction, we will have to multiply both numerator and denominator by square root of x minus square root of x plus 1. Doing so, we will get the numerator as square root of x minus square root of x plus 1, and denominator is multiplication of two parts. The first is square root of x plus square root of x plus 1, and the second part is square root of x minus square root of x plus 1. Now we can apply an identity a plus b multiplied by a minus b is equal to a square minus b square. Here a stands for square root of x and b stands for square root of x plus 1. So using this identity, we can write the numerator as it is square root of x minus square root of x plus 1. The denominator according to this identity is square of square root of x minus square root of x plus 1. We can further simplify it as the numerator as it is and denominator is square of square root of x. It is x itself, negative sign and then x plus 1. It is square root of x minus square root of x plus 1 divided by x minus 1. So x and minus x, the result is 0. Finally we will get square root of x minus square root of x plus 1 divided by minus 1, or you can just change the sign of the terms in numerator. It is square root of x plus 1 minus square root of x. So what we have found? We have found that the fraction 1 upon square root of x plus square root of x plus 1 is nothing but square root of x plus 1 minus square root of x. Using this relation, we can find the values of all terms in the left hand side of given relation. For example, we can say value of 1 upon 1 plus square root 2. Consider this. It is 1 upon 1 plus square root of 2. We can write it as 1 upon square root of 1 plus square root of 2. So according to this relation, the value of this fraction is equal to square root of 2 minus square root of 1. Similarly, we can say that the value of 1 upon square root of 2 plus square root of 3 is equal to square root of 3 minus square root of 2. Okay? And here we can see that the value of square root of 4 plus square root of 3 is nothing but square root of 4 minus square root of 3. So, we can explain the left hand side once again according to this relation. See how the first number 1 upon 1 plus the square root of 2 is nothing but square root of 2 minus square root of 1. Okay, it is left hand side. The second term is square root of 2 plus square root of 3. We can write it as square root of 3 minus square root of 2. Third term is square root of 3 plus square root of 4. It is square root of 4 minus square root of 3. Then square root of 4 plus square root of 5. We can write its value as square root of 5 minus square root of 4. The next is square root of 5 plus square root of 6. We know that according to this relationship, the value is square root of 6 minus square root of 5. Next term is square root of 6 plus square root of 7. We can write it as square root of 7 minus square root of 6. We can write 1 upon square root of 7 plus square root of 8 as square root of 8 minus square root of 7. And the last term is 1 upon square root of 8 plus square root of 9. We can write it as square root of 9 minus square root of 8. So it is all about the left hand side of this relation. We see that we can cancel square root of 2 and minus square root 2 because their sum is 0. Similarly, we can cancel square root 4 and square root of minus 4. Square root of 3 is cancelled by minus of square root 3. Here, square root 5 is cancelled by its negative minus square root of 5. Square root 6 and minus square root 6. Square root 7 and minus square root 7. Square root of 8 and minus square root of 8. All are cancelled. The remaining terms are minus of square root 1 plus square root 9. We know that square root of 1 is 1 itself. So minus of square root 1 is minus 1. And square root of 9 is 3. And minus 1 plus 3 is equal to 2. And it is the right hand side of the given relationship. To the right hand side.